Hello? 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 Let me pull up my audio and make sure everything's working. I don't know why the music decided to be a bit of an odd direction. Hello? Welcome. Oh, okay. String beats is failing me. Nope. Nope, nope, nope. Okay. Hello, hello. Hello, hello. Welcome. Alrighty. Welcome. Welcome to stream. Hope you're all doing well. Hope you can hear me alright. Okay. This stream, I have homework to do. So we're doing homework. Calculus. Alright, let's do that better. Let's see. Okay. Ah, fuck. Nope. I ain't drawing a straight line. There we go. Yeah. Calculus. Is that readable? Looks like it should be readable. Cool. I like that color. Orange. Then let's get a purple. Okay. We're doing some calc review. This is for calc 2. So let's start off. I'm just looking at this because it's a graphing question. Ugh, not even the right words. I sadly don't have a glove, so it's not going to be as easy for me to write. Figure shows the graphs of f prime and the integral of 0 to x for f of t dt. Identify each graph. Okay, so we got that. Oh, my wrist. I mean, I'm just looking at it to try to figure out how to draw this nicely. One. Two. Okay. Then we have something that kind of just goes. Ugh. Let me see if I can just trace this. Here, let me get rid of all this. Sure, good enough. Then we got B. And then C. Sure, something like that. I could try to get a picture of it. That would be a lot of effort right now. Okay. Okay. Doing that. And we have A. B. And C. Cool. The graph of, or F is graph now. If we're looking at this, we want to look at we want to look at all of these points of intercept. I think these are all supposed to align here. Or no, they don't. Yep. Okay. So F, in this case, if we look at our functions, the F prime will represent the graph that shows the velocity, or the change in slope of graph F, while the graph of F, graph of the integral of F of from 0 to X will show the area under the graph. Or the antiderivative, in which case we don't know what that is. But we can look at how I'm just trying to look at my thing. I believe is correct. This is my reasoning. Graph B is F. F prime is graph A. No, I'm looking at it. I'm sorry. I think graph of F prime is graph A. And then the integral of 0 to x for f of t dt. Oops. Sorry, I haven't used this drawing tablet in a while. Dt is graph C. Because if B is graph of F, and then its derivative will be at 0 when the slope of B is 0. Which is... no. I think this is right, but I'm not really sure if it's right, to be honest. I'll have to look at this. Okay. I don't wanna do that. Let me change something on this. Degree. There we go. I want more like that. All right. Take all this. Okay. Get all this shit out of here. Oops. Okay. Put that stylus side back out. Now we're on to 2. Number dos. Fuck, that's a shade 2. There we go. Better. Compute. The integrals. Okay. I don't know why they changed the numbering system, but now it's A. Compute the integral of y minus y to power of 1/2 over y dy. All right. How do we break this up? I want steak. I think. Fuck. dy. I want to go over here. Let's u be equal to y minus y over negative 1/2. I think I can do that. U sub it. Because now if I take du, it'll be equal to 1 minus a 1 plus 1/2 of y minus 3 over 2. Dx. Right. Okay. Now I can do... Fuck. Leaving shit everywhere. du -1. No. Wrong. So now du divide by 2 -1/2, which is equal to y to -3/2 dx. Okay, that's better. Ugh, sorry, being perfectionist about it. Is that even possible? I don't know. Let me check something. I might be going about this completely wrong. Yeah, I did it wrong. Let's see. Anybody in chat smart and know what this is, what to do here? Oh, I'm dumb. Yeah. Okay. So we can do... No, let me check this. This is equal to, yeah, no, this works. Y over Y. Y over Y minus I to negative 1/2 over Y dy, what is equal to the integrand of 1 minus Y Y to 1/2 over 1, right? One minus which then goes to 1 minus 1 over, oof, my brain. Y to the power of 3 over 2. It's supposed to be 3. Dy. Which you can then rewrite as 1 minus Y to negative 3 over 2 dy. Which now, that's easy enough. So that's 1 integrand, the integral of 1 dy minus the integral of Y to 3 over 2. Come on, go. There we go. Dy. Which gives you Y minus it's Y plus now 1/2 of Y power of negative 1/2, because it's the plus 1 bring it down, and then plus C, which then as its final form, let me move my screen down a bit so it's not so uncomfortable to write. We get Y plus 1 2 square root of Y under 1 plus C. I'm gonna do better C. There we go. Ugh. Rotated itself. There we go. Let me make sure me check that that is correct. If I can check that one. Yes. Yes, that is correct. Or no, that's not correct. I made a mistake already. Shit. Because it is not 1/2. Sorry. I make a lot of simple mistakes. I need to, that's what I'm doing here, fixing them. It's y plus 2. I'm not gonna write there 2. There we go. 2 y to negative 1/2 plus c. Which then simplifies to y plus square root of y under 2 plus c. Okay. We have that. Oh, shoot. Whoops. And we got b, right, down here. Where we want to find the integrand. Of 0 over from 1/4 pi to 0 for secant squared of x dx. Right? Let me check this. Oops. But sure, close enough. Okay, so secant is, oh god, trig identities. Nope. I hope that wasn't too loud. All right, there we go. Secant is 1 over cosine. That's right. Squared. Let's see. What is let's see what this ends up. Tangent. Why does it go with a tangent? Trig derivatives. I want to make sure I know why. Okay. Well, that's just because it's tangent. So I'm just stupid. Okay. So I'm going to mark over here. D over dx. Here, let me spice it up with a different color. D over dx of a tangent of x is equal to secant squared of x. I just need to remember that because the school says so. I have to memorize, not learn how to use. Okay. Which means we can go straight to the tangent of x from pi over 4 to 0 and integrate that. Which means we get the tangent of 0 minus tangent of pi over 4. Which is equal to tangent of 0 is 0 minus tangent of pi over 4, which is 1/2. No. It's not 1/2. It's 1/4 because well, pi over 4. This is pi over 4 over here. This is 1/4. 2 pi. This is 0. This is 0 and 2 pi. This is pi. Pi over 4. Which is square root of 2 over 2. Square root of 2 over 2. So it's one of the few places where tangent is 1. Because tangent is opposite over adjacent. So it's sine of x I'll do this in a different place. Okay. So tangent of x is equal to sine of x cosine of x. Anyway, I can rotate this. No. Okay. I want to double check that, make sure I'm not insane. Tangent of x. That's not what I needed. Sine over cosine. Yep, because it's opposite over adjacent. Which means it is -1. I can do better than that. No, I don't want a square, I want a rectangle. There we go. So that's 2 of them. Or 3 problems. You yeet it over there. Okay, next problem. Which is problem 3. Compute the integrals. Which now we have a, which is the integral pi squared over 9 to pi squared over 4 of sine square root of theta over theta d. Oh, I didn't get you. That's okay. So that's good. And we're going to use u sub here. So we can do let u be equal to the square root of theta. Du is equal to, let's see, 1/2 of theta to -1/2. d theta. Right? Let me get that a little less scrunched. So then we can take it and be 2 du is equal to d theta to negative 1/2 of d theta. Okay. Because now we also have to solve for the new boundaries, right? So we can say u1 is equal to square root of pi squared over 9, which is equal to pi over 3. U2 is equal to pi squared over 4, which is equal to pi over 2. Move that over and make sure we have no space. And we can set this equal to the integrand from pi over 3 to pi over 2, where sine of u over u 2 du. Okay. Now we have that. Which is equal to. I'm just trying to think of the next steps because class is not the greatest at teaching this stuff. Kind of just trying to keep up as best as I can. The integrand Let me look this up. I want to make sure that I'm doing it right. Okay. Symbol lab. Nah. Integral pi over 3 to pi over 2 of sine of u over u to the u. I don't know if the wolf one is better. I'm gonna use this one. I care more about whether it shows steps or not to understand. Whatever I was trying to do. Hmm. Hmm. Yeah, this one is just kind of useless. Okay. Symbol Lab, I hate you, but you're also one of the few that actually is consistently good. Fire for 3. How the fuck do you... Fire for 2. Sign of you over you to the you. Right, that's not solving the same thing. I squared over 9. I squared over 4. Sine of the square root theta over theta d theta. There it goes. Oh my god. I just say Symbol Lab is one of the worst. Yeah. The hell is C? Is it just saying it's inverse sine? I don't know. Because I thought that the inverse of sine was cosine. I don't think I'm allowed to use that though. This is where I just feel stupid. Yeah. Okay. Well, I know I can pull the constant out. Ugh. All right, let me check if I learned about the C. If we covered it in class, because I don't think we did. But I never know because the professor is not the best class, Canvas class layout. Yeah, I don't think so, but all right, let me check. Yeah. Interview. My professor didn't even transfer to U, so I don't know what she did with the U. Under a sign of U. Because apparently it just disappears, which doesn't make sense. me see if I can find the walkthrough without using the fucking C. Nope. That is not it. Nope. Alright, let's see. Magic Man. Integrals for you. Let's watch this. Okay, so we got U sub. Okay. Square root of x. Oh, okay. That was very confusing, not straightforward. Fuck. I understand now. My mind has been unlocked. So now we can convert this to pi squared over 9 over 4. We can say this is sine of the square root of theta times 1 over the square root of theta g of theta. Okay. And so this do that. That is equal to that. Because this is equal to 1 over square root of theta. G of theta. Right? So it does work. It's just okay. which then converts to the pi over 3, pi over 2, and it's just sine of u times 2 du, because there's 2 of these, which is what's found there. Cool. Now it's 2 times the integral of pi over 2 from pi over 3 for the sine of u du, which is equal to 2 times the integrand, or times cosine of x, or cosine of u from pi over 3 pi over 2, which means we get, let me move this down a little, two times cosine of pi over 2 minus cosine pi over 3, which is equal to cosine 2 times 0 minus unit circle again, pi over 3 square root of 3 over 2, right? Over 1/2, I think it is. Or no. 1/2 square root of 3 over 2. Let me double check this. I'm pretty certain that's what it is. Cosine of pi over 3. Yes, 1/2. Then if I say it sine of pi over 3, then it should be set somewhere that's not helpful. Yes. Square root of 3 over 2. Cool. So minus 1/2, which is equal to 2 times negative 1/2, which is just equal to negative 1. Cool. Got there. All right. Getting there. Ugh, that was horrible. Ugh. There we go. Something. Negative 4 to 0 for 30 t times the square root of t plus 4 d of t. Okay. All right, so start off by letting t, or not t, u being equal to t plus 4, right? Which makes du equal to dx, or I should say 1 dx which means they're equal to each other. But then I also want to know that t is now equal to u minus 4 that u1 will now be equal to negative 4 plus 4, which is equal to 0. And u2 is equal to 0 plus 4, which is equal to 4. So now we go from 0 to 4 for 30 times the square root of u times u minus 4 du, right? Which means 0 to 4 for 30 u square root of u minus 120 times the square root of u du. Which now we can take out 30. Well, actually, I showed them this earlier to make the number smaller, because I can do that. Yeah, fuck it, I'll just yeet it all. Oh my gosh. There we go. From 0 to 4. 4 square root of u times u minus 4 du, which is equal to 30 square root of 4 u times square root of u minus 4 square root of u du. Cool. It's groovy music. Hope you like it, chat. Tell me if you want something different, though. Alrighty. Which now we can do. Now we can integrate it. Well, I'm going to actually rewrite this. 0, 4 u to the power of 3 over 2 minus 4 u to the power 1/2 du, which is equal to 30 times 2/5 of u to the power of 5 over 2, right? Minus 4, no. Yes, 4 times 2/3 of u to the power of 3 over 2 from 0 to 4. Okay. Which I can simplify this with 2/5 u power over 2 u squared two-fifths of u squared times the square root of u minus let's see, 8 over 3, so 8/3 of u times the square root of u from 0 to 4. Just trying to simplify a lot of them operations, which is then equal to 30. Oof. So 2/5 of 4 squared times the square root of 4 minus 8/3 times 4 times the square root of 4 minus 0, because we know that our second region will be 0 since there's no constants that are going to affect it. Okay, which means this is 30 times 30 times 2/5 of 16 times 2 minus 8/3 of 4 times 2. Which is equal to 30 2/5 of 32 minus 8/3 times 8 . And now I'm going to multiply that in now so that I can simplify easier. So I'm going to say now this is equal to 60/5 times 32 minus well, here. I'll be dangerous. No, I'll do it. I'll say 30 times 2/5 times 32 minus 30 times 8/3 times 8, which is equal to I can technically delete this actually. Okay. We got all that. Which this leaves us with 12 times 32 minus 80 times 8 . And then we can say 12 times 32 . So 320 plus 64, 284 minus 80 times 8. So we get 640. Which is then negative 200 let's see 2640. We got six. Five. Negative 256. Cool. That is correct. All right, we got number 3. Shits. Why did it go so far back? It's being stupid. Yeah.
Print them out.
I mean, I can, yeah.
I'm trying to fit them all on 16.
I mean, it's just an infinitely big sheet. So it's just, might as well. Next question. No problem. Number 4. Find h prime of x if no, fuck. H of x is equal to the integral of x of 4 to the square root of x three z squared t to the 4th plus 1 dz. Okay. Let's see. a little bit more obvious. Hmm. Let's see.
What's the run? Yes.
7 to 10, Monday, Tuesday, Friday.
Friday?
Yeah. Monday, Tuesday, Friday. Yep. Yep. Yeah. Yeah. I'm not finding the reference on this. All right, I am gonna look this one up. I'm dumb. I'm very dumb. Find h prime of x if h of x is equal to integral of 3z squared divided by z to the 4th plus 1 dz from 4 to square root of x. Maybe. All right. I don't think it's gonna give us something. So I'm gonna go to the AI. The AI. Find, there we go. Fundamental theorem of calculus and chain rule. Yep. Okay. So, fundamental theorem in calculus. Fundamental theorem in calculus. Fundamental theorem because. Yeah. And chain rule. No, I'll scratch that right now. F of Z. Um, mm, Here, I'll grab that. Where is this? Mm, yes. So basically it says f of x is an antiderivative of f of x, where f prime of x is equal to f of x. No, shut up. My watch is buzzing at me. Okay. So in this case, it's saying fundamental theorem and a chain rule states that f of z is an antiderivative of f of z. Then so chain rule. Ugh, that you the chain rule, where it basically says d over dx of the integral a to g. No, that's not what I wanted. G of x over 4 f of z dz is equal to f of g of x times f prime of x. Yep. So here we can say let's f of z be equal to the function, basically z to the 4th plus 1, and then let g of x be equal to square root of x. Right? And then lower limit a is a constant of 4. So I'll say a is equal to 4. G prime of x is equal to 1 over 2 square root of x and so now I can just plug it in, I guess. So I can say h prime of x is equal to f of g of x times g prime of x. Which is equal to f composite square root of x times 1 over square root of x, or 2 square root of x, which is then equal to 3 times square root of x squared over square root of x to the 4th plus 1 times 2 square root of x under 1. Okay. Oh, I broke it. There we go. And now we can just simplify. Where it's 3x over x squared plus 1 times 2 squared x under 1 yucky math. Oh, I know it's not fun, but it is math, and it's the math that does a lot of things. I don't know what, because the teacher doesn't say, but it does things. Oof. So welcome to stream. Welcome to stream. Oh my god. Sorry. Okay, that's better. At least it's not business math. Yeah, where it's like math with words instead of variables. And so it doesn't make sense. Alright. I'm gonna get 3x. And then it's 2x plus 1. Or plus 2 square root of x. Let me double check that. Come back to me. Yeah. Ugh. Weird songs. Plus 1. Three x. I want to see what they tried. I want to see what it did. I didn't look at the last part. I don't know what it thought was the most simplest form. Yeah, I don't think that works. I don't think it works like that, but it got most of the way there. I don't think I can simplify that anymore. That I can see off the top of my head. And so there's that one. And that is number 4. Much, much less. All right. Scooched. Get the fuck out of here. There we go. Okay. Next one. Let's see. Fuck. Use the properties of integrals to estimate the value of the integral without the value without evaluating it. Oh, that is a long question. For the integral from -1 to 2 of 1 plus t squared dt. Okay. And I know we need to use extreme value. Fuck. Okay, I'm just going to rewrite this. Not going well for me. Extreme. Fuck. Value. Theorem. And what does that mean? Let's see. Let's see. Calculus modules. Step 4. The decimal integrals. All right. Found the actual name. This is called the closed interval method. That's not what I wrote. Okay. So you want to start by finding M, N, and M. Capital M and M. Okay. We want to find the maximum and the minimum value, right? So we're going to do f of t is equal to 1 plus t squared, and then 1. And then we want to use f prime of t, because that'll give us our critical point. Which means we then have let's rewrite this real quick. 1 plus t squared to negative 1. Right? So then we get negative 1 plus t squared times 2t. Which is then negative negative 2t plus 2t cubed. I think that's right. Oh no, that's not right. Because negative that squared times 2t. Which is then equal to just negative two t over Ugh. Just do 1 plus t squared squared. Oh, no. It erased my 2. Okay. And we want to find the critical point. So when is it 0? So f prime of 0, or no, f prime of t is equal to 0 when t is equal to, okay, let's see, 0 between -1 and 2. We got, I guess, just 0, because you can't actually remove t at the bottom because it's always positive since it's squared. Yeah. So only when t is 0 does it actually, does f of prime t actually be 0. And I can pull this up on Desmos to check. Excuse me. F of t is equal to 1 over 1 plus t squared, right? F prime of t then if I do f prime of x, which I can also do my function to make sure it's correct. So 1 plus t squared squared. I can do, whoops, negative. And there we go. It matches, which means that I did my derivatives correctly, which is good. We can see the only point is at 0, 0. Which means that's likely our maximum or minimum point. So we can do f of 0, which is equal to 1 over 1 plus 0, which is equal to 1. And then we have f of -1, which is equal to 1 plus, well, not 2. 1, because the negative gets squared out. So then it is just 1/2. And then we have f of 2, which is equal to 1 plus 4, which is equal to 1/5. And therefore, this is our minimum, min, and then the max. Our max 1 at x is equal to 0. And then our absolute min is 1/5. Fuck. At x is equal to 2. Okay.
Yeah. Yeah. Yeah.
Yeah. Okay. Because now we have our minimum and our maximum values. 1 and 1/5 at x equals 0 and x equals 2 respectively. Which means that for our integral, one-fifth is this less than or equal to 1 over 1 plus t squared, which is less than or equal to 1. Okay. And so now we have, fuck. No, hide. Get out of here. Property number 8, which says if m is less than or equal to f of x, which is less than or equal to m, then m times b minus a is less than or equal to the integral from a to b where f of x is less than m times b minus a. So now we can apply that to here and say that this is going to convert to 1/5 times 2 minus -1 is less than or equal to the integral. That's not very integral-ish. Let me go down a little bit so I can. The integral from -1 to 2 of 1 over 1 plus t squared dt is less than or equal to 1 times 2 minus -1. Which then simplifies to 3 and 3. Which implies to 3/5 is that less than or equal to the integral of -1 to 2 from -1 to 2 of 1 over 1 plus t squared dt, which is less than or equal to 3. See if I can get this boxed. Fuck. Can I rotate this? I don't want to rotate it. I don't want to delete it. Okay, better. I'll take it. We've done it. Now we have estimated the value of the integral of 1 over 1 plus 2 t squared from -1 to 2 without actually evaluating it. You know. Fuck. It's removing my selection. Yeah, you get to live over here now. And so I want to deal with you later. Okay. Halfway through all the problems. Ugh. Okay. Now some slightly harder ones, I think. Okay. So problem 6 says let R be the region bounded by the curves y is equal to x cubed and y is equal to x. I'll move that over here. I'm gonna get one line. Okay. So number 8 says find the intersection points sketch the region Then find the total area. Okay. Got it? So let's start by making a graph. Please save me with straight lines. Nope, doesn't save me. There it goes. Okay. And we know y equals x is just going to be this. And we know that y is equal to x cubed. It's going to start at 0, 0. And then let's say it process it. Well, first, we can actually just find the points, then we can scale our graph accordingly. To find the points, point of intersection, you want to simply just put them equal to each other. Basically, you just do f of x is equal to g of x. So in our case, it will be x is equal to x cubed. Easy. So now we can say 0 is equal to x cubed minus x, which means 0 is equal to x times x squared minus 1, which means 0, which means x is equal to 0, 1, and negative 1, because 1 and negative 1 can go into x squared, and 0 goes into this outer one. Now we can say that 1 is here, 1 is there. Okay, let's not have background music, jeez. It's getting increasingly bad playlist. Okay. And then we know that it'll be what's an easy one to do? One half cubed is 1/6, which means it's like down here. Then we can just mirror it. And then we can say that 3 halves cubed is 9/6. Um, 9/6. Ugh, my brain. 3 halves. So 1.5 cubed. It's not 9. It's 27. Over 27 over 8. That's right. Which then is about 3 point something. Which means it's like, it's gone out here. Doesn't take long until it's gone. Which means it's not very much, but it's something like that. And so the region that we want to look at is the one right here. And the one there. Okay. Alright, sorry. It's being stupid. It's being stupid. Where are these? Oh, arrows. Okay. So the point of intersection, we got those. So now we want to find area. But which area will be equal to basically the integral from -1 to 1. So from here to here. And then we want just the area under the curve. So we have x, the larger function, at least in the positive region, is x minus x cubed. Actually, no, I want to set this up differently. We want the area from 0 to 1, right? Because we want the area of a function is the larger function minus the smaller function. And that's our area as an integral. So a is equal to the integral from a to b for f of x minus g of x dx, where f of x is greater than g of x. So we want x to be great. X is greater from 0 to 1. So x minus x cubed dx plus from -1 to 0. I can do it by 0. Sure. Then x cubed is greater than x itself. Then it's x cubed minus x dx. Which makes it equal to x squared raise the power and multiply by that value. So 1/2 x squared minus 1/4 of x to the 4th from 0 to 1 plus 1/4 of x to the 4th minus 1/2 of x squared from -1 to 0. There it goes. Now it decides to work wherever, for whatever reason. Now, we basically just solve, which means that will be now equal to b minus a in this sense. So 1/2 times 1 squared minus 1/4 of 1 to the 4th minus, in this case, 0. So 0 times 0, 0 times 0. Or we have 0 to the 4th, which just multiplies to get 0, and 0 squared, which multiplies to get 0. So it's just minus 0. We can simplify that ahead of time. And then we have b, so 0. And that will be the same thing as before, where it just simplifies to 0. I mean, we got 0 minus 1/4 of -1 to the 4th minus 1/2 of -1 squared. And then this is all going to be equal to, we can start simplifying now, just doing the math. So 1/2 minus 1/4 probably just remove the brackets for this one. So this can be just 1/2 minus 1/4 plus 0 minus 1/4 minus 1/2. Because -1 squared and -1 to the 4th both come out to just be 1. So then we have 1/4 plus 0 minus negative 1/4, which is equal to 1/4 plus 1/4, which is equal to 1/2 units squared, because this is an area. And so this could be similar. Unit squared just means like foot squared, where it is literally 1 by 1 box, where this is a foot and this is a foot. That's just all it means. But it's abstracted because we don't know what kind of units it is. Oops. And so it's just that. Okay. I mean, technically, we don't really actually have to write this because there's no specification of units. So we're just finding the area as a numerical value, which is just that. Okay. B down here. Ugh. Okay. Let's S B D E subset of the region R described above. Let's see. I don't know how far across I wrote. Okay, I wrote to the edge. Described above. Which, ugh, is in the first, I'll capitalize this, first quadrant only. Set up an integral to find the volume of the. I apologize for my handwriting, it's not the greatest. Of the solid obtained by rotating S around 5. S about the axis using the shell method. Ooh, my wrist is hurting, I'm sorry. All right, let me pull up the shell method so I can write that down. Whoops. Cylindrical. Shell. Method. There we go. Okay. The professor didn't actually put the definition on the reference page. Not very helpful. Okay, there it is. So, the show method basically says the volume is the integral from A to B of 2 pi x times f of x dx. Where this is the circumference. And that is just a function. So the height. Sure. Which means by using the shell method, our height would be just f of x minus g of x, right? In our first quadrant, if I'm remembering correctly, fuck. This is 1. I think it just goes clockwise. I believe. 1 negative. 2 negatives. I don't remember. Something like that. But this is 1. So this is the one we're wanting to work in. Which, if you remember, means that we are working in this region. Up here. All right, let's go back down. I'll paste that there. Okay, that's the working area we want to be in, which just means that it will be, our height is x minus x cubed, like we did before. And then our circumference, or our integral, is just going from 0 to 1. And so the actual integral will say that the volume is equal to the integral from 0 to 1 of 2 pi x times x minus x cubed dx. And that's it. This one is very easy compared to the washer method to set up, I think. And so now I can say C. Fuck. Not so much. C. Let's see if I can. No, it doesn't want to go down. Fine. Be that way. C wants us to now set up an integral defined the volume of the solid attained by rotating S about the line y is equal to -1 using the disk slash washer method. So the disk slash washer method no, end it after this question or after this problem. Disk slash washer method. Let's see. Yes. Disk washer method basically says the volume is equal to pi times the integral from A to B. For f of x squared dx. And I'll do an example with this one because this one's a little bit more confusing. So an example. I don't know if I can really do an example on this one. I'm kind of out of time, but let's see. We have a drawing, and we already know y equals -1. So now, let me see. I should be able to paste it still. So now we want to rotate it about y equals -1. And we still only care about the region described here. Okay, so this is section S. So to set this up, we need the cross-sectional area, which is given by pi times the radius outer radius squared outer minus the radius squared inner. Right? Which is going to be then our outer is x and our inner is x squared or x cubed. So we get pi times x squared minus x cubed squared. Which is just equal to pi times x squared minus x to the 6th. So then that means that our volume will be equal to pi from 0 to 1, because we're still going from 0 to 1. From 0 to 1 for our area over here. Double check this. which is then just equal to that. So x squared minus x to the 6th dx. Fuck. Okay. And that would be our answer. Alrighty. There's technically 2 more problems, but I'm not going to get to those tonight, because I am sadly out of time. But thank you so much for joining. This one was a bit of a long one. See if I can zoom out far enough to where I can actually move it. Okay, easy. All right. Thank you for hanging out. Hope this was fun-ish. Math is math, but it's cool. Math is cool. Math is easy when you actually do it. But yeah, thank you all for coming. And hope you all have a good night. Bye-bye.